Hi, my name is Nate Michaelov. I'm a Senior Solutions Engineer here at Snyk, and today what I want to talk to you about is just how easy it is to get up and running with Snyk Code. So if you're familiar with Snyk at all, you've probably seen this slide before. What it really just shows is the way that the modern software application has changed. Modern applications are composed primarily of open source components, dependencies pulled in, containing pre-built functionality that a lot of your first-party code now just stitches together. But just because applications are predominantly open source doesn't mean the risk surface of your first-party code has gone away. That's still handling a lot of your business-critical functionality. It's still important to make sure that you have insights into what's going on in your first-party code, and you want to identify any security issues there before it moves to production where it could potentially cause issues. Now, static analysis isn't a new concept. It's been around for decades, and there are a number of legacy solutions still on the market today. But they've never really caught on with developers because they just aren't built for developers. These tools are noisy, they generate a lot of false positives, they're slow, they can take hours to days to scan, and a lot of times they require configuration of the application and different platforms that just goes against the way that developers build software. Right? They might have to build it in a specific way that doesn't match what a production environment would look like. They might have to add UIs to their workflow that require pre-configuration of different profiles, management of different security policies. So it's just obtrusive, it slows things down, and it's not a great experience for devs. So when we created Snyk Code, what we were aiming to do was really build a dev-friendly, dev-first static analysis tool. That means it needs to tie seamlessly into developers' workflows, it needs to be unobtrusive, and it needs to be fast. And that's what Snyk Code is. It provides actionable results with low false positive rate, with insights into how to fix the issues that it found, gleaned from real-world open source projects, and it does it quickly, about 10 to 50 times faster than the next fastest solution. More than that, it ties seamlessly into a modern SDLC. We can fit in the IDE, we can sit in the repo, monitoring changes to the code while developers are collaborating around new features and functionality, and we can also provide gating in the CI, making sure nothing of critical severity or whatever your tolerance threshold is reaches a production environment where it can become problematic. So let's hop over first into the Snyk platform. I'll show you how to get onboarded with the new Snyk Code application. Then we can take a look at how this would fit into a couple of different places in the SDLC. So I've got my Snyk Code platform here, no projects onboarded, but I have connected it with my GitHub. That lets me import any of the different repos that I'm looking at so that I can get insights into the different layers of the application. So to onboard an app, I just go to Add Project and select the repos I want to import. There's no need to pre-configure any profiles on the platform. You don't need to package anything in a different way. We're just going to reach out, pull up the components you want us to assess, and provide insights in you right within the platform here. We're going to go with Juice Shop to start, which is just a known vulnerable open source application. We'll just click Add Selected Repositories, and you'll see the import start. A lot of times when teams come to us, they're actually not even looking for static analysis. They might be investigating our open source tool, looking for container scanning, but they'll typically try it out because it is just so easy to get up and running right alongside the other solutions. As you can see, everything imports quickly, and all of the different components are available for review right here. If I click this drop-down, you can see our static analysis findings, open source, container, and IAC. Let's hop into the code analysis, take a look at some of the results, and get a sense of what things look like when they're scanned with Snyk Code. You'll see that every Snyk Code finding is analyzed and categorized according to MITRE's CWE system, and we provide prioritization scoring, seeing what things are occurring frequently in places with high concentrations of code. But more than that, what you'll see is actionable guidance for each of the findings that we have. We lazy load these code snippets from the repo so you can see the full flow data through the application, identify how these issues are being introduced, and also provide fix examples. So if I scroll down, we can take a look at some of the different findings available in Snyk Code here. Take, for example, this SQL injection. If I click Full Details, you can see how it's occurring in the application, moving from the request all the way down to the sink, where it's actually reaching the database query. To help developers understand, we provide a fix analysis that includes both an academic overview of what the issue is, as well as some real-world examples pulled from permissive open source libraries. This shows the diff where the issue was identified and fixed and allows developers to actually see some real patterns of how to implement these things in their own applications, rather than just giving vague guidance around what they should do. Again, the focus is always on highly actionable results. When you scan with Snyk, you may see fewer flaws found overall, but the true positive rate's significantly higher. If, however, there are things that don't warrant addressing, things that you don't want to deal with right now, you always have the ability to ignore or suppress findings, temporarily or forever. This won't remove them fully from the platform. You'll still see them under this Ignored tab, but it lets you focus in on the critical things that you want to address and really begin scoping work just to the issues you want to see. So that's great. That's Snyk Code in the platform. We can see how we would onboard a repository, see information over time, track different issues. But if we want to look at it from the developer's perspective, what we really need to do is hop in the tools that developers use. So let's take a look in the IDE, the repository, and the CI. Here I've got IntelliJ, pretty common IDE for developers of different languages. And what I want to show you is just how easy it is to scan with Snyk Code. I have the plugin installed, and you'll notice that you can actually perform a couple of different assessment types with that Snyk plugin. We can do open source, static analysis, or look at code quality. Right now, we're just looking at static, so I've selected just security code issues. If I click Run Scan, you'll see the analysis kick off. Again, because Snyk Code is so fast, we don't need to minimize the analysis that we do or provide a restriction around the full assessment. This is a full application scan, looking at everything within the application in context, doing interfile analysis, and providing insight into things exactly the way that we would for the repo integration or the CI. You can see full parity of the findings we have here, along with what we found in the repository, and what we'll see within the CI as well. You'll see full data flow, again, tracking where tainted data is coming into the application, how it moves through the app to a point of execution, as well as those permissive open source examples, so that developers can go out and review real-world cases and implement the fixes in their own apps. So this is where developers should be starting their assessment, looking at the code while they're writing it, making sure that they're not introducing new things, and working through the backlog of any issues that might exist. Now, you can't always guarantee that developers will scan and fix here. Towards that end, we want to make sure that we can implement at the points of collaboration within the SDLC, not just the points of solo work. So if I move over and check out the repository, you can see how we integrate there from a workflow perspective. So here's the repo for our juice shop application. This is exactly what we onboarded through the Snyk UI, and it's what we scanned within the IDE. But this is also the place where developers begin to collaborate with each other. In the IDE, I'm just working on the code that I'm writing for the new features I'm implementing. Within the repo here, we start to review each other's code, merge in changes, and we want to make sure that we're catching anything that might introduce new risks, typically through a pull request workflow. So I can see where new changes have been recommended for the code, and we can see how Snyk Code can guard against anything that might introduce new risky functionality. If I take, for example, this pull request here, read into query data, we can see our automated tests have already been done. As the PR was opened, we automatically checked all the different Snyk assessment types, looking at open source security, licensing, and Snyk Code, and failing because we saw a new issue introduced. If I click Details, you can see in the platform some more detailed information. It looks like a modification to the query here actually produced a SQL injection, so we prevented it from being merged in. We can alert the developers and make sure that they get this resolved before it's merged back into the master branch and can potentially introduce risk in a runtime environment. Working within the repository is a nice way to collaborate with where developers are and where they're actively working together, but it's not the only way to implement Snyk into your workflow. We can also sit in your CI systems and run alongside any kind of functional testing there, as well as acting as a gate that prevents any risky functionality from reaching your production environments. If I look in my Azure DevOps, I have a pipeline set up that I'm using for Juice Shop. This is just a simple example, only running Snyk Code test, but it lets us see how static analysis could be situated alongside the other types of assessments that you might run within the CI. Very easy to get up and running, just 3 lines. We install the Snyk agent, we authenticate back to the platform, and then we scan, providing our assessment. You can set different severity thresholds or other criteria for pass-fail if you'd like to gate. or you can scan and simply allow it to continue if you only want to begin baselining the application. I can select Run, and we can look into the scan actually seeing the results in real time. We can jump forward on the queue, but we want to make sure that you see the full static analysis taking place within Snyk Scan because it is so fast. Again, this is something that we can implement easily without gating developers' productivity, just preventing risks of security from going forward. Snyk SAST kicks off, we install the agent, we run the scan, and we check to see if there's any high criticality severities. Since there are, the build fails and nothing reaches production. So that's Snyk Code. It's just that easy to get up and running with at any point in your SDLC. We can meet developers where they are, scan quickly, provide actionable feedback, and give you all the results you need in real time and where you need them. If you're interested, you like what you saw, you can give us a free try. Check out Snyk.io to get up and running. Thanks.